Every one of us will have a dream place which we wanted to visit within our lifetime. Even I'm having a dream place which I wanted to visit within my lifetime. The name of that is nothing but the Thriller Fountain in downtown of Dubai. What is the reason why I want to visit? That is nothing but the mesmerizing music as well as the dance of the fountain. And one more thing is we could able to see objects and things moving, but they are not moving according to the music, right? The music and the dance together is telling so many physical components to us, and so many physical quantities also associated with that. Piece of this fountain, what we are seeing here, the mesmerizing one, the fountain is going to have its height varying as well as the distance what it is traveling is going to vary with the help of another example as well. Our most favorite show in cartoon, the Tom and Jerry, right? You were able to see here it's going to take the Tom from here and it's going to take it over this side and from here to here, right? That means that when I'm going to consider this motion, you could able to see it's having an x-axis movement as well as the y-axis. So the fountain case as well as here the movement of Tom, both of them are having the variations in the x and y-axis. That's the same thing we are going to explore with this part of class. If you are going to have an object which is going to have a movement in x and y axis, that will be termed as motion in a plane. A plane will be having both x and y coordinates with that. So whatever the quantities associated with a moving object, like the velocity, acceleration, distance, displacement, all of them are going to be explained for a plane over here. Let us look into the video now.
Let us learn about the addition of vector by using the parallelogram law. We are considering two vectors, which is A and B, which is passing through the point O. The angle between them is going to be theta. The final resultant of these two vectors will complete the parallelogram with the parallel sides, and the diagonal which is drawn from the O represents the resultant of the two vectors A and B, which is C. Over here, the resultant vector C is going to make an angle alpha with the x component, or we can say that as the A vector. Similar way, it will be forming an angle beta with the B vector over there. Now we are naming the corners of the parallelogram as P, Q, R, so that the OP represents the B vector, OR represents the A vector, and OQ represents the C vector. Now I'm just extending this parallelogram to have a right angle triangle, which will convenient for us to write about the trigonometric ratios of the sides, and I'm naming that point as S. Then I'm drawing a perpendicular line or perpendicular bisector RT to OQ, and it's going to have an angle beta. According to the concept, alternative angles will be equal. Now out of this, I'm considering the triangle OQS, and I'm trying to write the Pythagoras theorem formula over here, which will be given by OQ square is equal to OS square plus SQ square. That is nothing but hypotenuse square is equal to adjacent side square plus opposite side square. Now we have to find out the value of this OQ, OS, SQ, so that we can simplify and we can get the answer in terms of the A vector and the B vector. where the OS is going to be given by, as from the figure, OR plus RS. Now the OS can also be written as A plus RS because we know the value of ORS A. Now we are going to take the next triangle over here, which is RQS. The similar way we are going to find out the values for the equation 1 only over here. So I'm taking the cosine ratio over there, which is RS divided by RQ. Now I know the value of the RQ is B. Then by rearranging this, I could able to get the value of RS as B cos theta. Let me take this as equation 3. Now we know the value of the RS and OS. We have to find the value of the OS only over here. So I'm taking the sine ratio, which is QS divided by RQ, or RQ can be written as B, so that by rearranging it or by cross multiplying it, I can get the value of the QS as B sin theta. Let it be equation 4. Now we could able to see it from the figure that the value of OS and RS, you could able to see the OS is going to be given by A plus B cos theta. That is RS, we found that as B cos theta. We are substituting it. Let it be equation 5. Now we know the value of QS and OS, so we are substituting it in equation 1. That means that A plus B cos theta the whole square plus B sin theta the whole square. The A plus B cos theta is being expanded in A squared plus B squared, that is B cos theta the whole square plus 2AB cos theta plus B sin square theta, where the B is common with the two terms that has been taken out. Cos square plus sin square is 1. That's why I'm writing them together over here. Then 2AB cos theta. Then what we are having, as it goes off as 1, A square plus B square plus 2AB cos theta, or you can write that as A plus B the whole square. Right? When you are going to look at this over here, the final equation is going to, what we are having over here is called as the law of cosine. That is, in terms of the cos theta, we have the resultant vector C vector over here. That is the equation 6 we are naming as law of cosine, right? Or this A square plus B square plus 2AB cos theta can also be written as A plus B the whole square, then root and that will get cancelled, then you will get the C vector is equal to A plus B. Now we are taking the triangle OQS again, and you could able to see that we are finding the sine value of it, which is giving QS over OQ according to the trigonometric ratio formula. From that I'm getting QS is equal to OQ sin alpha. Then QS can be written as OQ value is C from the figure, we know it. So C sin alpha, which has been taken as equation 7 over there. Now as this OP and RQ are parallel, RQ should also be of what? B vector only. So we are going to utilize that value in this triangle RQS over here again. Then the sine ratio is going to be given by QS over QR, or QS can be written as, QR can be written as B. So QS divided by B is equal to sine theta, or QS is equal to B sine theta, that is sine alpha. That can be taken as the 8th equation over here now. Now we are writing the C sin alpha is equal to B sin alpha from the equation what we got over here, right? Now C by sin theta will be equal to B by sin alpha, right? By rearranging this equation what we have over here, that is taken as the 9th equation over here, and we are going to take the other part of the triangle, which is OTR. And we are trying to find out once again the similar kind of ratio in this one, where the sin theta in this will be given by, that is sin alpha will be given by TR over OR, or the TR value is nothing but don't know, and OR value is nothing but A. So TR is equal to A sin alpha, which is going to be taken as the 10th equation over here. Now let us take the other triangle, that is TQR. So we are going to find the theta value only. But what theta? Sine theta. So sine theta is equal to TR by QR. We know the QR value as B. So sine theta is equal to TR by B. Or you will be having the value of the TR as B sine beta, which will be taken as the equation 11 now. Now we are going to compare all these values over here. So TR is equal to A sine alpha, TR is equal to B sine beta. So both of them should be equal, which can be written as A by sine beta is equal to B by sine alpha, right? Let us take this as equation 12. Now when we are going to come for the next term over here, the equation 9 and 12 is going to give us the comparison between the vectors what we are having here. That is, A by sine beta must be equal to B by sine alpha must be equal to C by sine theta, which is the relation between the alpha, beta as well as the angle at which the two vectors are being splitted over here. So A by sine beta is equal to B by sine alpha, or you can write that as from the figure. See, sine theta can be written as 180 minus theta. Then you can write that as sine beta is equal to B by sine alpha is equal to C by sine gamma. That gives you the angle with the third direction, which is taken as the 14th equation, and this is what is the required equation, which is called as the law of sines. So the law of cosine and law of sine will be using in the problems. For that reason we must know about it. That can also give you the value of the alpha and the gamma. So the alpha, gamma, beta are the angles which is being made by the unit vectors of x, y, z direction. We have seen that already, right? So gamma can be written as 180 minus theta, or sine alpha is equal to B by sine theta, what we have over here, which has been taken as the 15th equation over here, right? So this 15th equation is going to give us the relation between the angle subtended between the two vectors and the angle which is made with the x-axis over here. Now we are taking the triangle once again to find out the relation between this thetas what we are going to have. So we have a B sin theta over here and B cos theta. So we are trying to find out the value of the alpha over here, that is tan alpha. QS over OAS, which is adjacent over the opposite. Then OAS can be written as OR plus RS. Then OR is nothing but, from the figure it is very clear, it's going to be A, and R is going to be B cos theta, which we done already, right? So which is the equation 16. Equation 16 represents the magnitude as well as the direction of the resultant vector C vector. Now let us explore the formulas what we found with the help of the analytical method, how they are used to represent the magnitude and the direction. So the formulas are as follows. The first one is according to the law of cosines. C is equal to root of a square plus b square plus 2ab cos theta, where we know the angle theta as well as the component vectors a and b, which gives us the magnitude of the resultant vector C vector. When it is going to come for the second law, what we have done is law of sine, where the components vectors a, b as well as the resultant vector c is being connected with their sine angles or the sine ratios, which is of sine beta, sine alpha and sine gamma. From that, what is the magnitude we got as sine alpha is equal to b by c sine theta, gives as the direction of the C vector, and the tangential component what we got as the last formula gives us the magnitude of it. Now we are going to explore about the motion in a plane, that is in x and y direction. Here also the object is going to be in motion only, so obviously it will be having the physical quantities such as displacement, position, average velocity, instantaneous velocity, average acceleration, instantaneous acceleration. So in this part we are going to use the vectors to represent the position of them, or it is going to be displacement or whatever it is, all of them are going to have a vector because they are in a plane now, not in a single direction movement now. So the example what we are taking here will make us to understand what does this plane means. I'm taking a xy plane which is having the unit vectors as I cap and j cap. There I'm considering a point P which is going to have the coordinates of x and y as xy, and I'm going to look at this P from the origin, which means that the straight line is going to represent the position of the object from the origin. Now this P point, what I'm going to have, will be having two perpendicular lines which is drawn to the x-axis as well as y-axis. This x and y-axis perpendicular line are going to given by the x and y components of the B vector. The x component is going to be OXI, that is, which is nothing but xi, and the y component will be given by yj. So as a result of it, the resultant vector OP vector, what we named here, is nothing but r. So the resultant vector r will be given by the component of the x plus the component of the y. Similar way, now we have done it for the position vector. Let us look into the displacement vector, how it is going to be represented in the 2 dimension. So a representation of the displacement of a body over here. See the point P, what I'm considering here, that is going to be the starting position of the object. It's going to move to a point which is called as Q. Now the point Q will be having the position vector from the origin as OQ vector. If you're going to look at it from P, the object moved to the Q. So the displacement is going to be PQ, right? Now if you're going to look at it, the tail of this PQ vector has been connected with the head of the OP vector. Then according to the triangular law, what we know, the third side of that is the r dash, will be given by the addition of the OP as well as the PQ. That's the same thing we are writing here. R plus del r is going to give us r dash. Now what I wanted to know, the resultant vector del r, that will be given by r dash minus r, which has been taken as the first equation over here, and that represents the displacement vector of the given change in position of the object from P to Q, what we are going to have over here, right? Now we can write the r dash and the r component vectors over here, which is xi plus yj for the r dash, and for the r it is going to be of xi plus yj, right? So when we are going to come for the next step, we are just segregating the x components and the y components, which is going to represent exactly the displacement vector, what we are going to have it over here. Now the displacement vector, how to find it, we did. Now we are going to look into the next term, which is the average velocity. So what we are going to do here is nothing but, when the object is going to move from the point P to Q, obviously it is going to have a time variation associated with that, so that the average velocity will be given by displacement divided by the time interval. That's the same thing we are going to write here. The displacement vector is del r divided by what is the change in time is going to be delta t. So we are taking that part of that alone over here, and we are substituting the x and y components of it. So which can be written as del x divided by del t into I plus del y divided by del t into j. Del x by del t is nothing but the position change in the x, and the del y by del t is going to be the change in position as x. So it can be written as vxi plus vy, right? Now we are going to find the next one, which is going to be the instantaneous velocity. We know this factor very well, that the instant is the word meant for at the particular given time. That means that if I'm going to have the travel from 0 to 10 seconds, then within this 10 seconds I can take any one of the instant, I can find the position of the object or velocity of the object at that point. So we are writing limit delta t to 0, del r divided by delta t, which is the velocity of it. Now if you're going to look at it, we have different instants which has been marked over here, as you are seeing over here, between the point P to P1, as well as we are going to consider the point P to P2, which is nothing but the second vector, you could able to see, and P to P3. So at different instant we are considering the position of the object over here. So with the help of that change in position with respect to the time taken over here, at each and every instant we will be able to find the velocity of it, For example, if you are being in a car, you could able to find at 10:3 what was the speed of your car and in which direction you travel, right? That's the same similar thing we are trying to do it over here with the help of the graphical method what we have over here. So each and every time, what is the time you are going to calculate or what is the time you are going to notice is going to vary. In the first case, it's going to be t, next case t plus delta theta 1, the third case t plus delta theta 2, and the fourth case t plus delta theta 3. You could able to see the time is going to increase continuously over there, and the displacement vector is also varying. So at any instant, if you are trying to find out the velocity, then that is going to be given by the same velocity what you are going to have at the same instant of the starting. Suppose if it is going to have a uniform velocity. First we are trying to find out the direction of the velocity what we are having at the initial point. The direction is connecting the final portion of that, which has been split in the x and y components. Once again, we'll be writing the same formula over here. That means that at any instant in a distance time graph, the instantaneous velocity can be given by v is equal to vxi plus vyj. Correct? If you wanted to know the magnitude of it, we know it. We'll be taking the modulus of it, which is nothing but root of vx square plus vy square. That will give you the magnitude. And to find the direction, we'll be using the tan theta, which is y-axis variation divided by x-axis variation, and the theta will be giving you the direction in which it travel. So the instantaneous velocity also we found it now. Now we are going to explore about the average acceleration as well as the instantaneous acceleration. So the first one is the average acceleration. As you see it over here, I have taken the same xy plane with the same unit vector j and k, and the position has been taken as initially p, and the object is going to move at different positions. The arrows represents the different position of the object, where the acceleration will be given by, we know the change in velocity over time, then the change in velocity along the x and y component we are writing it, we are splitting and writing, so that it will be given by axi plus ayj. Now the last but not the least, we are going to find out the instantaneous acceleration of the object over here. Once again, the instant, at any instant, if you are trying to find out the acceleration of that, that will be the individual component along the x and y axis will be giving you the acceleration of it. The similar way we are writing change in velocity by time, then x and y component will write delta t, what is the particular time you are going to have, that you will be writing at the time what is the ax and ay you are going to have. That will be giving you the acceleration of the object at any instant throughout the motion. Correct? Let us explore about the equation of motion for an object which is going to have a constant acceleration, and it's going to have the movement in the x and y axis, that is in the plane. So I'm considering an object which is moving in an xy plane, and the initial position of that is going to be taken as p at time t equal to 0, and the position vector of that has been taken as r naught. The velocity of that has been taken as v naught, and the xy components of that is going to be v naught x and v naught y. Now at time t equal to t seconds, the object is going to reach the position of p dash vector. The position vector of that is r, and the x and y components of them are vx and vy, and the velocity of that is going to be v. So we are having two vectors over here, which is v and v naught connected by the tails. So the resultant of that, the change in the value of that will be giving you the resultant direction, and the change in velocity over time is going to be the acceleration we know. Change in velocity here is v minus v naught, and time is t minus 0. So v minus v naught divided by t, which can be written as a is equal to delta v over delta t, right? Or otherwise we can write this as like the first equation of motion. Do you remember? V is equal to u plus at. So we are having the a into t, or v is equal to v naught plus at, which is the first equation of motion. We got it in the normal way, but we want it in terms of the x and y coordinate, so that the vx can be written as v naught 0x plus axt, and vy can be written as, we know it, v0y plus ayt. So according to the x and y components, we could able to write it in a plane like this, right? And when it's going to come for the next one, average velocity, that will be given by total displacement over total time over here. So the same average velocity only we are going to have over here, but the displacement is in the x and y coordinate, so that you can write that as average velocity into time. What is the average velocity we are going to have it over here, and what is the time, total time we are going to have it over here? That's what we are going to write. So displacement is initial position minus final position vector, so r minus r naught, and average velocity is v, that is initial final velocity plus initial velocity divided by time, and 2, and time is t. So that we are going to simplify it, which is giving the equation for us v naught t plus half a t square, which we know already, that is s is equal to ut plus half a t square. Now once again we are going to resolve it, and we are going to write it for the x and y components, right? So the x and y component, if you are trying to write, it can be written with the help of x is equal to x naught. In the x-axis, position vector will be x, and the v naught will be given by v naught x, and the a will be given by ax. T is a scalar quantity. In the y-axis, r will be y, so y is equal to y naught plus v naught y t plus half a y t square. So we have written the second equation of motion, s is equal to ut plus half a t square, in terms of the x and y coordinate, that is for a plane over here. That has been taken as equation 3 and 4 over here, right? In the similar way, the third equation of motion can also be written in terms of the x and y coordinates, that is v squared minus u squared is equal to 2as. Along the x and y, we will be using the x and y components over there. Now in motion in one dimension, what was the one more thing we have done is nothing but relative velocity. So let us explore about this relative velocity in the two-dimensional motion over here. The same thing we are going to take. We are taking a plane where we are going to consider the objects which is going to be taken in motion. So the object, first one is going to move with the velocity of va, and the second object is going to move with the velocity of vb. Two vectors we are considering over here. The first vector va as well as the second vector vb, what we are going to consider. If you are trying to find out the relative velocity, if both of them are in the same direction, then that will be va minus vb, which we are aware of already. Now when it's going to come for the components of it, then how we'll be writing this, that we'll be looking into. Before that, the minus can be written as plus minus of vb, right? That means that it shows the opposite direction of that over there. Yeah, so when we are going to take the VA and the VB in the opposite direction, the resultant of that will be given by the a triangular law of vector addition, which is going to be of VAB is equal to VA plus VB, but here the VB is going to be of a minus sign. That's what exactly we are doing it. In the reverse way, if you are going to do that also, we will be getting the same answer for that over here. So that is what is the triangles as well as this opposite components over here represent as. That means that relative velocity with respect to a to b is equal to opposite of relative velocity of the object b to a. Now if you are trying to find out the magnitude, both of their magnitude will be equal only the direction varies.
In this video, we have learnt about the movement of object in a plane and the physical quantities associated with them, and how to represent them in terms of a vector. Hope so all of you understood this. Thank you, children.